when you have many repositories to manage and each repositories are having many secrets, keys, password, how would you manage them? Probably you will save it within your GitHub environment, max them further, or probably use some security management engine to manage it further. But how about rotating them? You will not have fun to rotate them manually, of course. Maybe you can create some algorithms or use the secret management system to rotate it further. But by doing so, probably you will lock yourself to the vendor itself. So you are understanding which point we are going forward. Yes, it is. We will be talking about how to manage the secrets and how to work with freedom in terms of security. Hello, everyone. Good day. This is Hillol, Habib and Nabi. Today's host for next 30 minutes. I'm welcoming you from Malmo, Sweden. You can see the famous turning torso here, working at Inca Group as a senior DevOps engineer. I'm married, having a sweet daughter who loves to make up herself. And of course, sometimes she does make up on my face while I was taking a nap. Yeah, and today we'll talk about a little bit how to build an agnostic solution, which is in terms of security, which is agnostic with HashiCorp Vault. And of course, it means that how to secure the SDLC with less dependency, and of course, how to manage it automatically. Before we begin, let's have a look what we will understand or what we will learn after the end of the session. At first, we'll learn the benefits of being agnostic in terms of security. Then we know how to manage them securely and seamlessly with HashiCorp Vault. And of course, finally, we will know dynamic security key management with HashiCorp Vault. Point to be noted here, we will not talk about how to onboard HashiCorp within your organization. That probably you will learn from the tutorials of HashiCorps. Well, the agenda for today, we'll know at first understanding of the solution, which is agnostic in terms of the security. We will know a little bit background about the secret management. We'll know how to manage a secret centrally with HashiCorp Vault. Then we will know a little bit about background about what is dynamic key and why we need it. And then finally, we'll know how to implement dynamic key within the environment. Of course, we will not be able to cover everything in details, but I will try to give as much information as it needs. At first, let's try to understand what is agnostic means. The term agnostic is an adjective. It means something relating to a hardware or software that is compatible with many types of platform or operating system. So if we relate that with in terms of security, so we are meaning here the security system that is compatible with many platform, many cloud solution, many system. So we are trying to make a generic security solution that is usable in many places. That's the idea. Probably it will not really be agnostic. Maybe it could be native. However, moving forward, we need to know why we need it. We are very good. Our current solutions working fine. Why we need to be agnostic? So in today's world, we are using many cloud providers like Google, Microsoft, Azure, AWS, Alibaba, and so on. What if we got a disruption someday? Even though we able to make a agnostic deployment, agnostic system solution or infrastructure quickly to other cloud, authentication with them differently might be complicated. So if we have a solution ready in hand, it will help us to migrate quickly to some other solution or some other system or some other infrastructure in no times. How about price? Sometimes some provider might increase their price, some provider might decrease their price. So probably we can take advantage of it. We can make many small simplified or many solution which is kind of compatible with many solutions together. Why we will make some things complicated unnecessary? We can make a one generic solution that will be helpful or usable for all. And then the solution, which is agnostic in terms of security, it is future proof. So we need to think of the future as well while making anything. Well, before moving forward, let's see why we started this talk. Basically, in our team while working, we found secrets everywhere. And I'm sure you will find your development environment also. We have secrets in our security analysis, that we have our automated testing tools, we have our monitoring tools, and so on and so on. And every tools on API needs a security and authentication within the system. To do so, we are saving the secrets, probably in the GitHub, probably in the environment variables, or probably we are masking it with GitHub secrets. But that might not be always a good idea to do, because it might not be safe, might not be rotatable, or might not be readable. But of course, you will not love to manually change it. When you have 20 or 30 or 40 repositories altogether, and each of the repositories are having many secrets, of course, you will need to hire someone just to rotate the secrets manually. And that's not a fun job to do, I'm sure. And to find a solution to that problem, we thought of HashiCorp Vault. Yes, HashiCorp Vault is actually doing the job. It is storing the sensitive data and information within the environment, and the access is tightly controlled, and we have different interfaces to access them. CLI, we have UI, we have HTTP API interface, and so on. So let's see how secret management works within the HashiCorp Vault environment. We have this nice diagram. It describes all. We are going to see in next slide, step by step, how it works. Thank you, HashiCorp, for providing a simplified diagram. You can see the source here, and then maybe you can read in details how it works. But I'm going to describe how we did it within our system. So as I said, we need to onboard the Vault yourself. So after onboarding, we need to pass some specific parameters that's needed by HashiCorp. For example, the Vault address, namespace, and token, and so on. And then we need to integrate Vault within our system. There are different kind of integration mechanism. It could be with token, it could be with April. For our case, we have decided to go for April. We need to enable the April within Vault environment. Then after enabling, it's time to save your secrets or load your secrets. You can do it with your UI of the HashiCorp, or either using the Vault command from, where you can put the secrets there. You can put n number of secrets together, or maybe one by one. It's your choice. Point to be noted, these are only examples. That is actually for the test case. Might not be perfect always, but this for your inspiration, I'm providing some of the examples. So after putting your secrets within the Vault environment, it's time to create policy. That policy will define what the capability areas of that path. Within the path in HashiCorp, they defined basically a type of language where you can access the tokens seamlessly. So when we have created our, we have saved our token, we have created our first policy to read. Now it's time to define a role. By that role, we can really access the secrets from Vault. So this role we can create from the prompt of the HashiCorp CLI. We can define then necessary policies and bind that policy with that role. This policy and role together will create our first token. So basically what we are doing here, we are keeping our secrets. To access these secrets, we need a token. So meaning from our local system or from the pipeline with a orphan token, we can access those secrets and use it in our environment. Now here we can see we have created our orphan token, and that orphan token is basically has no parents, and this orphan token is valid for next 32 hours. Sorry, 32 days. That means 720 hours. And this token will be used in the workflows. Well, so far so good. Probably you are understanding or maybe getting confused. But of course, I hope you will get some information by end of the session. Well, here you can see as I said, we have a pretty good number of applications to manage and then repositories to manage also. So in that case, there should be a smart way to manage it. What we have our main workflow, which is the workable workflow, and we are keeping a common repositories where we are keeping our actions to manage or to orchestrate or to provision further. We are passing necessary parameters like Vault server URL, namespace, and token to do that. So these small two clouds will describe what I have said just now. Here is our workflow. You can see our workflow repo, which working repo will have the workflow file, and that workflow file will call the central repositories, and this central repositories is having the action, the file, and that action file basically will be used to log into the Vault, fetch the secrets, and save them as an environment variable within our environment. For our case, we are using GitHub Actions to do that. Probably you are understanding by my terms and so. Then we'll see what is the action file. We have our action.yml file. This action file, we are passing token, server URL, namespace, path, and role name that we have created while onboarding. And basically, we are ramping a Docker file. And that Docker environment basically call a Python script to provision our Vault interface within the pipeline. So basically what we are doing, I'm briefing it again. Now we have our action file, and in action file we have our Docker, and Docker will call our Python script. And these Python scripts are having all the necessary commands to call Vault, log into Vault, extract the secrets, and save it within the environment. So to understand further, let's move forward and check our Python scripts. Firstly, probably the audience, you have good understanding on Python. Of course, this is not a Python course, but the important factors that we need is we need to import necessary environment. Then after that, we are passing our Vault URL, namespace, pipeline secret paths, role name, etc., as a parameter. So these will be used by Vault itself to orchestrate further. The path actually is something that is interestingly could be managed by HashiCorp. Within HashiCorp environment, we can create path and namespace or folders, we could say, according to the type of secrets that we are managing. Sometimes this could be a secrets related to securities. It could be secrets related to monitoring, or maybe this could be secret related to pipeline, or maybe some secret could be application related. So you can manage it accordingly and pass the pipeline as a path variable, and then the Vault environment will extract according to your path. So here we can say that, okay, to log in to GitHub, we need role ID and secret ID. In this script, we can see how to extract the role ID and secret ID. Then after that, we need to log in with app role mechanism. We are logging into app role, and then after that, we are reading the secrets from the Vault namespace. We have our secrets, read it perfectly. Time to write it. Yes, we are writing here with the scripts in the GitHub environment. So when we have the things are in GitHub environment, it's easily manageable. So here you can play the trick that when we have in the secrets in the environments, you know the GitHub environment, we have we can call it and save it. So you can with the script you can play around. You can mask it further, or the way you want it, you can do it here with the script. So when you have it in the environment, it is easily accessible through GitHub environment variables. You can see we are using Polaris, which is one of the SAST tool, is security pipeline security scanning tool that we are using. We are extracting that URL and token and using it within our pipeline. Well, good. So far, probably you're confused enough to understand. So we have our HashiCorp Vault management system. We have a better understanding now. So beginning, I've talked about orphan token. The orphan token is a token that is used to authenticate with Vault itself. So this orphan token is valid maximum for 32 days or 720 hours. After that, it will be basically destroyed. So we need a mechanism to renew it, or maybe to rotate it. We'll talk about to renew it here. So how we can renew itself. With this next slide, you'll see how we have created a action file or workflow that is actually renewing chronologically. So we have to again, method is post and path is the variable that we will need to provide here. And then with this, we can create a orphan token. So there are different kinds of token. If we make it orphan as a true and renewable as a true and attach the policy accordingly, it will be followed there. So here we can see the workflow. You can see we have done a cron job. The workflow will be running every morning, 6 a.m. And then with a simple command, Vault token renew, we are renewing the token. So I think it's clear enough. Hope you will get a brief idea or understanding how to manage the secret within the environment. Now, our second problem is the authentication key that we talked about. Let's see the background of it. We try to make our infrastructure agnostic or cloud native. Yes, we did it. With a single trigger, we can provision our infrastructure with many clouds. But problem is authentication. Good cloud native, fine, but we need to create separate authentication methodology for each of the cloud provider, and we are locking ourselves with them. So rather than creating many solution, we can go for one simplified solution that will help us with one trigger. So we have our password everywhere. We have our authentication everywhere. Whatever service even we use, we need to authenticate it. So hence, we thought of dynamic service account key. So we have created I have written here GCP service account because the example will be provided in GCP environment. So the good side of it is it's dynamic, meaning it will be created on the fly and it will bind with IAM policies. So we do not need any dedicated service account to do so. So it will be automatically cleaned up after use, and it is quick and short term. There are two options for this. One is role set, another is static accounts. Role sets is to provision the first time service accounts, and static is for when you have an existing service account, how to manage as a dynamic. Static account is that thing here. Well, good. Now let's see the flows, how to use dynamic service accounts. So again, I have written GCP here. The reason is that the example will be in GCP. But this flow is a basic flow that will be usable, that will be used by any cloud provider. So basically, I have inspired by the source we have written. It's one of the HashiCorp guy. So I have just inspired by him. You can click on the link and see in details how he did it. He has used Azure as an example, but I tried to make it generic. At first, as usual, we need to enable ourselves to use and define assigned policies for HashiCorp. Then from there, we will receive the client ID and secret ID. Then after doing so, we need to set client ID and secret ID as the variables. Modify then the provider of the Terraforms, and then provide the credentials from there. After that, in 6th step, we need to Terraform will be used to provision with HashiCorp Vault itself. So we will use Vault generic secrets in this case, so that Vault can issue a secret permission with the cloud that we are using. So Vault has a permission which is provisioned by Terraform, and then Vault will create a new secret within the cloud environment. After that, of course, Vault will read the secret and receive it and save it within HashiCorp environment. So this is basically the thing, creating the secret within the cloud environment and getting back to HashiCorp Vault to save it with them. So it has become independent in that case from the cloud itself. Now Terraform will be able to read the secret from HashiCorp to use it further. So point to be noted here, in 6 and 7, we can modify the provider and cloud so that we can use it as a generic solution. When use is done, we will define a time of the token itself or key itself to be destroyed. Very nice and good. No keys, no problem. Whenever you have, it's like that, you have your key, let's say for your door, you have a key for yourself. That key is generated. You give that key to password to your door is open. You can go inside. But that key is invalid after one use. It is destroyed. So there is no way anyone can enter to your room. It's like that. Well, we have our system, but of course, as I said in earlier slides, it could be different, little bit different for each of the cloud providers because they have their own way to authenticate. We can make an abstract solution with Terraform here. We have our different, modules of the Terraform. We can use microservice buckets and Kubernetes and so on. So I have created a factory pattern here that could be usable. You can get inspired by it and you can make it use of it as you need. So now we have our explanations before. Let's see a little small example. Basically, the example I could have been given everything in details, but for the time constraint, it's not possible. I'm showing some little score snippet. So in this snippet, we can see we are reading the access token and keep it in the environment variable to use further. So here, basically, we are reading the token and then saving it, access token, in the GitHub environment to use it further. So this basically the token is it is holding the JSON key created by the service account temporarily. Then you can see here, we are authenticating with Google with this access token. That's the JSON key. Here is also, we are authenticating with the JSON key, which is kept in the GitHub environment variable. That's as simple as it is showing here. There are some steps, of course, you need to follow, but it's actually worth trying it. Well, we are almost end of the session. Let's try to summarize it further. What we have learned. Number one, we have learned a central vault to store the pipeline secrets. This would help to avoid vendor dependencies. Access system is tightly secured and automated with minimal human interference. That means less possible to make errors. Secondly, we have learned the use and flow of dynamic secrets using HashiCorp Vault. There are no need to create a key or secrets and save them somewhere. You can do it on the fly. It could be generated on the fly and expires after use. Very nice. So what you can do next? Well, if you are experienced in Vault and Terraform, it's worth trying it. You can go for it. But and if you know, of course, there are a lot of solutions. I would love to hear from you if you have better suggestions. And then there could be many ways to implement it further, but the describe technique is one of them. You can try as you go. Then finally, if you are new in Vault or Terraform, what you can do, go start the tutorials, and then it is easy to follow. Maybe you can, then after that you can come to this point and like get inspired by this session. So sun is setting almost for me. All the service providers had its own way to manage the secrets, and then the solution they provide to secure the environment. But it depends on the developers. It's your choice, your call, which one is used. Keep in mind, managing secrets centrally might be easy, but sometimes it is messy. But it depends on your application, what type of application, what type of environment you are using. Yes, it is always better to do automation and, of course, try to avoid vendor lock. This altogether will help you to secure the environment. So with that saying, I am saying you a goodbye. Thank you all for listening to me. And I would love to hear from you. You can write it to my handles, or maybe you can email me, or you can write comments to this YouTube streaming. Thank you very much. Here are the references for your information. Probably the slides will be shared later on by HashiCorp. With that saying, thank you. A big hug.